So this is part 2 of chapters 5 and 6, part B, I guess. And you can see here on the screen where we left off last time. We talked about the two different banks, investing options, and we did the rule of 72, which is a rule of thumb for how long it takes for money to double. So we're going to continue on. We're going to, once again, we'll get to the outline later, just going over some basics of time value of money before we go through that. So let's assume you wanted to buy a house. For $45,000, and you're going to make 25 annual payments and be charged an interest rate of 8%. Now, just to let you know, kind of interest rates right now are like half of 8%. If you go back over time, 8% is kind of probably about the average. So your parents probably had a mortgage over 8% at one time. 25 annual payments, not real common. More common would be 30. 30 and 15 are probably the more common. Now some of you may be thinking, how can you buy a house for $45,000? Well, let's just look on Zillow to see if there is anything for $45,000. Okay, so here I brought up Detroit, typed in 45,000, and here we have a house. Let's see what it looks like on the front here. Not the best. There you go. So probably what we would typically call a crack house. And so you can get a house for $45,000. You know, the kitchen could use some work. But in all seriousness, there was another one I found here that didn't really look too bad. Look at that. See? So you don't need to just buy a trailer for $45,000. You can have a real home. All right, so let's go back to this example. So you want to buy a house for $45,000. My first question is, what would be the minimum annual payment? What would be the minimum annual payment? You can use your calculator here. You can even use your financial calculator here. And what I'm asking is, how much would you at least have to give the bank so that at the end of the 25 years, you would not owe more than $45,000? You would still owe $45,000, but you wouldn't owe any more. There's an easier way of asking the question, but I just want you for the moment to think about it this way. How much would you at least have to give the bank? So you can pause me, try to do it, use your calculator, come up with a number. All right, and the answer is, well, before I give it to you, let me ask you another way. What is the interest cost on the house? So if you just paid the interest, because remember, there's two parts whenever you do a loan. There's the principal and the interest. Principal is what you borrowed. Interest is what the bank is charging you in addition. So if we borrow $45,000 at an interest rate of 8%, the annual interest would be $3,600. Okay? So think about the business that a bank is in. Okay? So what business is a bank similar to? Okay? Well, what does a bank do? They lend money, or another word for like lending money is like rent. Okay? So they rent money. So imagine when you buy a car, or not buy a car, you rent a car. What happens? You go to the car rental place and they say, okay, it's $50 a day. And if you rent it for one day, $50, and then you give the car back. If you rent it for 3 days, $150, but then you give the car back. So the rent is like the interest. Okay? The longer you keep the car, the more interest, the more rent you have to pay. The car is what you borrow. That is like the principal. Okay? That's like the principal. You always have to give that back sometime. How long you keep it depends on how much, how much interest you're going to pay. Is going to determine how much interest you're going to pay. So same thing if you rent a house. Many of you are renting a home right now, and the longer you stay there, the more rent you have to pay, but eventually you have to give the home back. So with a loan, that's what you borrowed, the $45,000. if you just pay the $3,600, that's like the rent, if you will, on the money. If you pay that every year for, let's say, 45 years, how much would you owe the bank? So all you've done is pay the rent. So remember, if you borrow the car for 3 days, you pay $150. If you borrow it for 4, $200. But then you always still owe the car. You always have to give the car back. So in this case, you could pay $3,600 every year for 45 years, but you would still owe $45,000. So you have to minimally pay the interest, otherwise you're going to owe more than what you borrowed. So if you give the bank $3,600 plus anything extra, let's just say $200, the bank's going to say, okay, you paid us more than the rent, more than the interest, so we're going to take that $200 and subtract it from the principal because you've paid more than the interest. So now you're starting to pay on the principal, which reduces how much you owe. And that's how most people borrow money for homes, is that they pay more than the $3,600. So in this case, I'm just going to write actual payment, not minimum payment, is $4,215. And some of you may have done that if you used your financial calculator. I'll show you how to get that number in another session. But for now, just know that if you borrowed $45,000, 25 years, 80%, your payment would be $4,215. So doing that calculation, we can now set up what we call an amortization schedule. And you probably did this in accounting. Amortization schedule. And you will have a question on the quiz about calculating some of the numbers on here. So we have 4 kind of categories, well, I guess 5 if you count the years. 1, 2. We're just going to do a few years here. So you're going to start off borrowing the $45,000. The payment we just calculated because I gave that to you. We will calculate it later at some point in time. The interest on the first year would be $3,600, 8% of $45,000. So then this last column is how much is the principal declining? How much do you owe? Has it changed? It was $45,000. You gave the bank $4,250, but $3,600 was interest. So that's not helping any. So all we do is subtract the difference between those two numbers, and we get $615. So then this comes over to be $44,385 because we subtracted the $615 from it. Payment stays the same every year. What's going to happen to the interest? Up, down, or stay the same? Well, since you owe less money, the interest is going to go down. I'm just rounding these numbers off. It's going to be about $35.50. Therefore, this number is going to go up a little bit. And we're just going to do one more year here, just so you can kind of get the hang of it. Payment stays the same. Interest, because we're taking interest on the new principal part, $717. Okay, so this would go down to year 25. Now, let's just say after 3 years, you came into an inheritance, or you came into some money, and you're thinking, okay, I want to go to the bank, pay off that loan. You remember you borrowed $45,000, and you're also thinking, okay, I gave the bank over 4, 8, 12, 2, 4, 6, over $12,000, like $600. So you say, okay, I know there's $12,000 here. I've given the bank, that's like $33,000. This is where a lot of people get very depressed when they go in to pay off their loan, and they're like, well, no, it's not going to be $33,000. Well, why? Because a lot of that payment went to interest. How much interest? 3, 6, 9, 10, about 600, about 10,600 there. Okay. So out of your 12,600, over 10,000 went to interest, which means that the amount that went to the principal was only about 2,000. So instead of reducing your loan by 12,000, it's only going down by about 2,000. So that means you would owe about $43,000. And if you did this next row, that's what you would see. So yeah, it's very depressing when you first buy a home and you look at how little your principal is going down, but it gets better as you get near the bottom, and that's the way it is for everybody. Okay, so that's an amortization schedule. Okay, so let's talk about kind of direction of money. So if we're looking at time, and um, here is today, and we're going to look at 8%, $100. In 1 year, we have 100. We end up with 108. In 2 years, we end up with 116.64. And the way that we got these is we took 100 times 1.08 and 100 times 1.08 squared. So when we go this way, it's what we call future value. FV, future value. Because as we go to the right, in this case, money is growing. It's what we call compounding. Okay, so that's the term, compounding. Because money is growing. Now, I gave you these formulas, last class. What if we go backwards? What if we go backwards 1 year? What roughly would you think this number is going to be? Right? Most of you said 92, which is pretty good. 92, because look, 8, roughly 8, we go backwards, minus 8. Okay. The question is, how do we really get this number? And the number is 92.6. So how do we get 92.6? So think if you can do that. So notice that when we go into the future, we're multiplying by a number greater than 1, therefore it gets bigger, it compounds. But when we go backwards, the number gets smaller. And when it gets smaller, it's what we call, starts with the letter D. What word represents going backwards or getting smaller with the letter D? And it's what you love when you go to the store. You always want to get a what? A smaller price, a discounted price, okay? So this is what we call discounting. So you need to know those terms. Compounding is when things get bigger, discounting when they get smaller. When we go backwards at 8% for 1 year, we still have that $100 we started with, and we have the 1.08, but instead of multiplying, we're going to divide. And that gives us our 92.6. So figure out what it's going to be 2 years. 85.7. 100 divided by 1.08 squared. Okay? So that's the math behind using, I'm going to call these lump sums. Okay? So typically when we do these problems, we kind of have, for the most part, 4 problems. We have lump sum, present value, future value, and then we have payments, present value, future value. Okay? And sometimes there's a combination of those to work the problems to get a little bit more difficult. Okay? So you need to figure out, are you going future, are you going present? And a lot of times it's just a matter of just taking the verbiage, putting the numbers into the calculator, and then you only have one variable left, and that's what you're going to solve for. Okay? So that's future value, and that's present value. Okay, so taking that into note, okay, let's say that you want to buy a TV, okay, and you go into Best Buy, and you don't have much money in your checking account, you don't have a credit card yet, and you go into Best Buy and you see the TV and you say, okay, how much is it? And they give you a price and you say, I can't afford to pay that right now. Can I make payments? So they say you can make 5 $100 payments, and they're going to charge you 8%. That 8% is already included in that $100. So here's what it looks like. You make the payments at the end of the period. So that's the way we always assume payments are set up. They're at the end of the period. Okay. So first question. What is price, of TV? What is the price of TV? So where would the X be? The X is going to be what is the price of TV, not in 5 years, what is the price of the TV today? Okay. So the first question, is it greater, less than, or equal to $500? What do you think? Pause it. Okay, so what we're going to do is we're going to bring all of these 100s back to today at 8%. So this is going to be, this one's going to be 9260, this one's going to be 8570, and how do we know that? Because if you just go back 3 minutes, those are the numbers we just calculated. Okay, and if we keep bringing all of these back, if you add all of these up, they would add up to roughly $399.30. So that is the price of the TV today. So you could either pay $399 right now or make five $100 payments. And the reason why the 5 100s add up more to the $399 is because you're getting charged interest. That's factored in there. Okay, now let's assume you go there to buy the TV and you think, you know what, the TV's just too expensive. I could take those $100 and I could put them into the stock market and I could make 8%. Okay? So now the question is, how much would it be in the future? Okay? So this would be present value. What is the future value amount? Okay? So now we're going to take all of these 100s and bring them into the future. Okay? So what would this 100 be worth at that point in time? What would we multiply it by? Simply 1. Okay? Why 1? Because it's not going backwards, it's not going forward, it's simply there. The next one is going to be multiplied by 1.08, so that'd be 108. The next one, 1.08 squared, so 11664, and so on. Okay? So if we add all those up, we get roughly 586, we'll just call it 70. Okay? So that's the future value. Third question. Let's just say I said whoever gets the best score in the next quiz can have one of 3 prizes. I will give you $399 today, or you have the option of getting $586 in 5 years from now, or you can take the 5 $100 payments. Let's assume that whatever money you got, that you could take that money and make an 8% return on it. Which of the 3 would be worth the most? Don't worry about inflation or anything, just simply which one of the 3 options would be the most? Present, future, or the payments? So take a minute. Okay, so before you answer it, let's just say that you chose the $399. Using your calculator, what would that, how much would $399 be worth at 8% for 5 years? Okay? So you could do it in a couple different ways. You could use your financial part of your calculator if you know how to do that, or you could do the math that we've done before, which is say we multiply it by 1.08 to the 5th. Okay? And when you do that, you get 586. So what is the answer? They are all the same. This is about time value of money. Time, different times. So if you remember from my last video, like right in the middle of it, there was music playing and you kind of heard my mouth going and you're thinking, what is going on? It was really weird. It's because I was trying to talk a little bit over it, but I was playing the music by Pink Floyd and the song is called Time. Didn't work out too well like how I tried to do it, but anyway. We're looking at money, which is why we call it time value of money. So today, price is $399, the value is $399. In 5 years, it's $586. Over time, it's $100. It's like saying that in 1925, gasoline was 25 cents. And in today's world, it's like about $3.30 or something. I forget the exact numbers. But these two numbers are in essence the same. They're at 2 different points in time. Okay, so we have present value, we have future value, and then we have payments. Payments are not either present or future. Okay, they're just over time, right? Okay, so we're now going to go to the handout. I just want to make a note on here. So you can see the QR codes there. Those are problems that typically cause students a little bit more problems. So just scan that, and each one will take you to a YouTube of like 2 or 3 minutes that explain that problem directly. So that way when you're kind of going through them, if you're like, oh man, I kind of forget how to do that, you don't have to watch this entire video and try to figure out where it is, okay? So I thought that would just make it a lot easier. You can see there's a whole bunch on the other side there. So I'm not going to go through those problems here because you can easily do them on your own through YouTube, right? So starting with number 1, which is worth more, $1,000 today or $2,000 in 12 years from now? So you can do this 2 ways. You can either take the 1,000 into the future or the 2,000 back to today. It doesn't matter. It's simply saying which is worth more. We have to put them in the same time frame to figure out which one is worth more. So if we had to estimate what the $1,000 is going to be in 12 years, what do we know about money at 6%? Remember the rule of 72? Says that 6 and 72 is roughly every 12 years money doubles. So we know that the $1,000 would be really close to 2,000. So we can't really estimate based on that because the numbers are so close. So if you plug it in your calculator, 1,000 times 1.06 to the 12th, you would get an answer that way. Or I would suggest using your financial calculator. So on your financial calculator, a couple of things to know. So I'm just going to write here, calculator. So the big thing is if you're using the VA2 Plus, is always want to do this, hit the second function and the clear time value of money. Not the CE, it's over there, the third row down above FV. You want to clear your time value of money registry every time because it keeps numbers in there and it'll screw up your answers. So make sure you do that. Okay. So for this question, if we're trying to calculate the future value, we would say 1,000 is present value. So we type in 1,000, hit the PV button. We type in 6 and then hit the IY key. You don't have to put 0.06, just 6. And 12 in the N key. And then compute future value. Compute future value, and you should get a number of roughly 2012. Now, if you want to change the decimals, okay, you would hit the second function and then the decimal button, and it'll ask you how many you want. You know, you maybe put 4, then I think you have to hit enter maybe. I forget. Anyway, that should get you close. Okay, so the answer would be 2012 is greater than 2,000. Okay? So the answer is the $1,000. And if you took the 2,000 back to today, you would get a number less than 1,000. You would get the same answer in essence. Okay? So that's number 1. Number 2. Number 2 says you want to retire and you need 500. So I'm really big on these timelines, because I think it really helps some of you that don't like, worded problems, and, just if you can put them on a timeline, I think it takes a lot of that out of it. So you see that we got 500,000 every year for 10 years, and you got 10%. How much do you, plan to retire, you need 500,000 in 10 years, and then the question is, what are the payments? So how much do you have to put in every year? So you should know that if it was 0% interest, if you're just putting the money under your mattress, it's going to be 500 divided by 10. It's going to be 50,000 each year, 50,000, whatever. But you're getting 10% interest, so you should know that the number shouldn't be quite as high as 50,000. So try to think logically through some of your answers just to make sure you didn't go present instead of future value, whatever. Okay. So I think that chart is pretty straightforward. So now we just plug in the numbers. Where is the 500,000? That is in the future. So you'd hit 500,000, future value, 10 IY, 10N. Compute, what are we trying to calculate? Present value would be right here if we were just trying to compute one lump sum, but we're not. We are trying to compute the payments. Compute the payments, and you'll get a number of 31,373. 31,373. Okay, number 3, question number 3. So here we have an investment that costs $69.30 and it's going to pay $2,000 a year for 4 years. And so the $69.30 is today, present value. These are all equal amounts, therefore these are all equal payments. There's your payment button. 4 is your N. The only thing we don't have future value, don't need it. It's saying if you invested $69.30 and got $2,000, what is the interest rate? What is the IY? So compute IY after you've entered all those things in there, and you get what? You get error. So you get an error, which is fine. It just means that you missed one thing. So when you put in the numbers in the calculator is saying, okay, you've got $69.30 positive, 2,000 positive. There was no inflows versus outflows. It was all receiving. You received $69.30, you received $2,000, you didn't spend any money. So it can't calculate a return. So whenever you are calculating an I or an N, one of the sets of numbers has to be negative, okay? So think about it this way. You're spending $69.30, so that's going to be an outflow or a negative number. So type in $69.30 again, hit the plus minus key, make it a negative, hit present value. You don't have to enter in all the other things. And now compute IY, and you should get 6%. 6% is the answer. Okay? We'll do one more. We're going to skip number 4 because I've given that to you on the QR code. Actually, yeah, I'm pretty sure I went through all of it. Just remember for number 4 that when it says you put a 10% down payment, that means 10% of 50 is 5,000, and therefore you're borrowing, your loan is 45,000. And by the way, this is the question number 4 is where it's the same house problem as the Detroit house that we bought earlier, and this is where you find out the payment is $42.15. I'll just tell you that's present value, 25 years is the N, and 8 is the IY. So whenever you do a loan problem, it is always a present value problem because you're always borrowing the money today. Okay, number 5. So before we get to number 5, imagine there's a wealthy alum at OU, and they tell OU that they're willing to give OU $1 million to provide scholarships. Okay, scholarships. I know I didn't spell it right anyway. Okay, but they want the money that they donate to OU to come back to their heirs whenever they die. So how could they do that? Well, they could give the money to OU. OU could then invest it and take the interest off of it, use that money for scholarships. So let's assume that OU makes 6% return on the money. Okay? And therefore, how much would this $1 million be able to pay out in scholarships in the first year? Well, 6% of $1 million is $60,000. Okay? How much would they be able to pay out in the second year? So in the first year, they had $1 million. They made 60. They paid that out in scholarships. How much do they have left? They still have $1 million. And if they're still making 6%, how much did they get? 60,000 again. So how long could they do this? They could do this forever, in perpetuity. So perpetuity basically means like always. It's always going to happen. So question number 5 is labeled perpetuity. So this is what we call a perpetuity question, and it's asking the numbers I just went through, which is $1 million at 6%, And the answer is simply 60,000. So you could say the formula, I don't really have a good formula here, principal, the $1 million, times the interest rate equals the annual payment, if you will. Okay? So on the quiz, you're going to be given 2 out of 3. So I could have said if the interest rate was 5% and the annual payment was that you received was 50,000, what would be the principal? Well, you take the 5%, divide it into 50,000, and you get $1 million. Now I end up having a lot of students miss this. That looks really simple, but on the test, I'm going to give you a number that's going to be a lot harder. It's the same process, but I'll get a lot of students that will miss that question. Okay, so that's it for part B. The next one or two, we will just work on finishing up the rest of these questions. And that's it for chapters 5 and 6. I know I labeled it chapter 5, but really it's both 5 and 6. 5 is more lump sums, 6 is more annuities or payments. Same thing.